So, friends, we have taken this new question of the variable separation. Question is e to the power y plus 1 cos x dx plus e to the power y sin x dy is equal to 0. Now we have to solve this differential equation. As you know that I have already discussed the concept of the variable separation, how we separate the variables and how the terms of x will come with side of dx and the terms of y will come with the side of dy. So here we have to separate if possible. So what we will do, we will try to just write down this equation in form of dy by dx. So this will become dy by dx is equal to minus e to the power y plus 1 cos x upon e to the power y sin x. I think, right? And this is the terms of y e to the power y plus 1 upon ey. So this will come in this side, and the terms of x like cos x upon sin x will come with dx. So I can write ey upon e to the power y plus 1 dy, or if I want I can write in this side, no problem, and dx will be cos x upon sin x dx, integrate, and this will become equal to 0. Now if you want, you can consider this as a t. If you consider e to the power y plus 1 is equal to t, so this will become e to the power y dy is equal to dt. So this term will become dt upon t plus cos x upon sin x. This will become cot x, and the integration of cot is equal to log sin x. So this will become log sin x is equal to some, you can say, c1, and this will be log t, and t is equal to, we consider e to the power y plus 1. So this will be e to the power y plus 1, and log is also, so if you want you can multiply both things. Sin x is equal to c1. So this will become e to the power y plus 1 sin x, then e to the power c1, and we are going to give the new name that is equal to c. So this is the answer of this differential equation. If any condition is given, you can apply the condition, and that will be the answer. So this is the question and this is the answer, and I hope for that you are getting all the points how I am proceeding to solve this problem. So let's take another example. Another example is 1 plus x y dx plus 1 plus y x dy is equal to 0. So I think this is also easy question. You can follow the previous method as I have told you. So you can write down this in form of dy by dx. This will really help you that how you can separate the terms. So dy by dx will be 1 plus x y minus upon 1 plus y x. Now you may think that you can solve this question by homogeneous differential equation. So it is not possible, because here there is degree 1, but in this side there is no degree. So you cannot solve by this homogeneous differential equation. If you want, you can try, but you will get to know that it is not solvable by there. So you have to follow this method as I am going to tell you. So you can write 1 plus y upon y dy plus x 1 plus x dx. So you can integrate this one. If you want, you can put a dx in that side. Otherwise, it is also good to write everything in one side. This will be more good when you see. So this will become 1 upon y plus 1. 1 upon y plus 1. 1 upon y will become ln y, log y, and plus 1 is equal to plus and plus 1 dy. So integration will be y plus this is given that x upon 1 plus x. So you can write down like this: x plus 1 and minus 1, and x plus 1 dx is equal to c1. C1 is coming because of this integration. So now you can divide by x plus 1. So this will become 1 minus 1 upon x plus 1. So this will be ln y plus 1. So this will be x minus 1 upon x plus 1. So this will be ln x plus 1 is equal to c. So this is different because some constant will also come because of this integration. So I am considering another constant. So this will become ln y upon x plus 1 plus x plus y is equal to c. So if you want to write down all these terms in form of y is equal to something, so you can write c minus x minus y, that will be in power of e and multiply by x plus 1. So these are some numericals and you can solve. Let's say I am also going to solve one another example which will help you to define this type of concept, and I am hopeful that this much example is sufficient to understand this concept. So let me take another example. Question is 1 minus x square 1 minus y dx is equal to xy 1 plus y dx. So this is our problem and we are going to solve this problem. So if you want, you can just write down this 1 minus y in the denominator of this terms, and x will come here. So this will become x 1 minus x square upon x dx is equal to y 1 plus y dx upon 1 minus y. So this can be written like this: 1 by x minus x dx. You can integrate. This will come in this side, so this will become plus y 1 plus y minus 1 dy. So this will be dy. You can integrate this ln x minus x square by 2 plus if you want to, how you can solve this, y square plus y. So if you write down y minus 1 plus 1, you can solve like this: y minus 1 plus 1 1 plus y dy upon y minus 1. Now if you want, you can divide this one. So this will become 1 plus 1 upon y minus 1 multiply by y plus 1. I am just arranging this term so that I can solve. Actually this is a partial fraction. We use the partial fraction, then this can be solved. But this is also a way of arranging these terms in partial fraction. So you can write down this term like this: 1 plus 1 upon y minus 1 multiply by y plus 1. And now if you want, you can multiply this. So this will become y plus 1 plus y plus 1 upon y minus 1 dy. This is the, but here this is also going to be problematic. So you can again write this term. You can write down y minus 1 plus 2 upon y minus 1. So y minus 1 will be cancelled out. So this will become y minus 1 plus 2 upon y minus 1. So you can write down this term: 1 plus 2 by y minus 1. So you can write down this in place of this one. So this will be 1 plus 2 by y minus 1. Now it is very easy for you to solve. You can write down is equal to 0 is equal to 0. So it is very easy now to solve. So you can say ln x minus x square by 2 plus y will be y square by 2 plus 1 1 2 2y plus 2 upon y minus 1. So this will become ln y minus 1 is equal to c. So if you want, you can write down ln x and here 2 ln y minus 1. So this will become ln x multiply by y minus 1 whole square plus plus y square by 2 minus x square by 2 plus 2y is equal to c. So if something is given, this is also answer. This is also an answer. But if you are getting another answer in your book or copy, so you can manipulate according to that, no problem. You have to only arrange these terms. Otherwise, this is also an answer. So these are something that we have to use. Mainly, we have to use the concept of integration. Sometimes that we have to remember that how we will proceed in the beginning. If you remember, if you get any clue to solve the differential equation in the beginning, then it is very easy to solve. And up to in the beginning and in the beginning you have to only observe, but in the mid of the problems and at the last you have to only use the concept of integration. But in the beginning you have to observe very carefully that which type of methods will be useful and will be beneficial for you. So you have to you have all these things in your mind and you have to proceed them to solve these problems. And I am hopeful that if you keep on solving and if you solve approximately 20 or 30 questions, then you can get the proficiency to understand that which method will be applicable in this type of problem. And I am hopeful that this will help you to understand the concept of differential equation. Uh, so this is something from my side. So thank you, friends.